Here's a question about reacting masses. In this experiment, a student has completely reacted 9.54 grams of copper to oxide, and the question wants us to show that the maximum possible mass of copper sulfate is around 30 grams. The first thing I'm going to do in this question is probably study my equation that they've given here. For copper oxide, it's 1 to 1 sulfuric acid to 4 lots of water, and then 1 mole of my product. Now the important ones here are the copper oxide, this one here, and my product, copper sulfate, which are in a 1-to-1 ratio. So this should be fairly straightforward to do. So what's my first step after studying the equation? Well, I would say the first step is to find the number of moles. How do I know that? Because my first piece of information is I have grams and I have a formula. So using grams and the molar mass, I can work out the number of moles of copper oxide. So for the number of moles of copper oxide, I just need to do 9.54 grams divided by the molar mass of copper oxide, which I can work out from the periodic table adding my atomic masses together. And if I plug that into a calculator, I find that that's 0.120 moles. After that first step, I can go back to my equation and see I'm 1-to-1. So my number of moles of copper oxide will be the same number of moles of copper sulfate. So in my second step, and when I'm trying to work out my mass of copper sulfate, which is what the question wants me to find out, remember, it's pentahydrate, so we can't forget those waters. I've got my number of moles, which is 0.120 moles, and I can multiply that by the molar mass of copper sulfate pentahydrate, which, if I work it out from the periodic table, adding all my atomic masses together, is 249.5 grams per mole. And that will give me the mass that I expect of copper sulfate, which, when plugged into a calculator, is 29.9 grams. And you can see that that's probably correct because 29.9 is very close to 30, as the question expected us to get.